anchor position. Mario Molina will fill out the last of the comments, and then we'll open it up after that. So, Mario.
Okay, thank you. Again, I'd like to thank the organizers for giving me the opportunity of being here today. Just very briefly, my background is similar to Barbara's in that it's not modeling or field measurements, but actually laboratory measurements. So I very much agree with Barbara's comments that it's important to get the mechanistics right, the basic science, the physical chemistry and so on, understanding that cannot be incorporated as such in the large models, but it's one additional component that is important in the overall fields. But what I decided to do, instead of talking about that part of the problem, I'm going to go to the other extreme, which has to do more with science policy questions. So I'm just going to ask a couple of questions. It perhaps will sound a little naive, but bear with me. If we go back a decade or two, when the questions were posed that RAM was beginning to answer, what will happen to the climate with CO2 emissions? What's the sensitivity of the climate to these emissions? Well, that long ago, of course, the understanding was the forcing is not really that large. If you look at what clouds do, a relatively small change in cloud cover would be very important compared to the sort of things we're doing with CO2. So it was recognized early on that the importance of clouds and aerosols. And so for some time, the idea was, well, there's just too much uncertainty in terms of predicting what the sensitivity would be. But later on, with more and more observations, the climate did start to change. It was observable, so you could put an upper limit into the effects of changes in clouds or particles. So that was important. First question is, to what extent is that upper limit coming from the cloud modeling or aerosol modeling itself, or was it just an observation about the changing climate? Okay. But then the next point, we saw Ram presenting a little bit about the forcings. Of course, the greenhouse, mainly CO2 forcing temperature going upwards, but aerosols of the anthropogenic aerosols the other way around. The other RAM also showed some of the IPCC results. So we have two RAMs with similar results here. But that poses a very interesting question, of course, which is connected to the first one I raised. So the two forcings going in different directions, we realized not that long ago that the greenhouse gas forcing was larger, and that's why temperature is actually going up. But the question is then, what will happen in the next few decades or towards the end of the century? And of course, all you knowing that aerosols, anthropogenic aerosols, hopefully the emissions are going to go down, but even if they don't go down, they are more or less a steady state because of their very short lifetime. So the amount in the atmosphere will be more or less proportional to the emissions, in contrast to CO2, where the amount is proportional to the cumulative emissions. So at some point, the greenhouse effect will sort of overwhelm the aerosol effect if we continue with these emissions. But now to the key question, just from the point of view, again, of science policy. We could look at the IPCC results or some other modeling results, but the point is that for science policy purposes, the most relevant scenario is the business as usual, because you want to show society what would happen if we continue doing what we're doing. The hope is that they will respond and we won't be in that scenario. But you're not actually making predictions of what's the most likely thing that will happen. You're making a projection, what would happen if we continue with large emissions, okay? Furthermore, then you calculate towards the end of the century, you get the IPCC averages, maybe temperature could increase 3 to 4 degrees and so on. But that's the most likely change, assuming the high scenario. But working with economists, working with again, the science policy community, that's not the most relevant question. Most relevant question is what's the most worrisome outcome? And the most worrisome outcome is actually in the tails. So if there is a 1 to 5 probability that the temperature will go up more than 5 or even 6 degrees, that's much more important, much more worrisome. Okay? And the question is, well, you can see that, first of all, in the IPCC results. Having been many years at MIT, one way I normally talk about that when I give talks is showing their roulettes. Okay, so you can see the probability, and indeed, when MIT's models, it's even worse. The probability that it will go above 5 degrees is 1 to 4 or so towards the end of the century with a high emission scenario. But take 1 to 4, 1 to 10, that's clearly an unacceptable, totally unacceptable risk for society. So the question here is that uncertainty? So we're talking about probabilities. Because, of course, the climate is a complex system, so you cannot do any better than talking about these probabilities. But how does this community judge that probability? Is it, if you consider your knowledge of clouds, aerosols, and so on, is that reasonable, this 1 to 5, 1 to 10? Or is it larger or smaller? That's a crucial science policy question. And of course, we heard a number of very interesting opinions that it could actually be worse, okay? Because if you have a feedback and the cloud cover diminishes a little bit, then it could be a lot worse, but maybe it could be the other way around. But anyhow, the aerosol impact is also quite interesting because the hope is that it will improve because as the standard of living improves, countries like China, perhaps eventually India and so on, the emissions, the particle emissions will, and the biomass burning and so on will hopefully go down. But if at all, that will make the climate impact even worse. Okay. So anyhow, the summary is I got sort of mixed opinions as to whether to be sure about that, the size of that risk. What do you think? Is it actually smaller or bigger? Or is there something that this community could do? That's a very important question that I want to ask, to decrease that uncertainty. Because everybody sort of knows that one of the largest uncertainties in terms of climate projections is the role of clouds or the role of particles. So what can you guys do as a community to decrease that uncertainty? Because that's crucial from the science policy perspective. I better stop there. Yeah.